Hello and welcome back. Once again, this is Teacher Jesse, and today I will be discussing with you about how to solve for the surface area of a solid figure. This is Mathematics 6 Quarter 3 Module 6 of the Davao City Self-Learning Modules. But before that, to those who haven't yet subscribed to my channel, please do not forget to subscribe and click the notification bell so that you'll get updates on my upcoming math tutorial videos. So we are going to start with the let us try activity of your module, which is finding the surface area of the following solid figures. The first one is a cylinder with a height of 12 meters and the radius of 5.2 meters. And the second one is a rectangular prism with a length of 7 inches, width of 4 inches, and the height of 5 inches. So, how are we going to solve for the surface area of solid figures? The surface area is actually the sum of the areas of the lateral faces. So it means the faces and the bases. So for that, we need to recall the formulas used in finding for the area of the given polygons or the figures, which is the most common figures. Let's say, for example, the parallelograms. We have the rectangle, the square, and the parallelogram. It is base times height. If it is a triangle, it is base times height divided by 2. If it is a circle, it is pi r squared. The derivation of this pi r squared is coming from this. If you take a look at this figure, this is a circle and it is divided into sectors. And if you are going to cut them with two alternating colors, we have I guess this is yellowish and this is blue. So if you are going to combine the wedge, it looks like this, and it's actually a parallelogram. And this is pi r, okay, pi r because the circumference of this is actually 2 pi r. Can you still remember? The formula in finding the circumference is pi times d, and diameter is 2 times radius, so 2 pi r. And it is only pi r because it is just 1/2 of the circumference, because the other half is on this part. And the base is just pi r, and then the radius is this one. This is the height of the parallelogram now, so which is r. And if you are going to multiply pi r, which is half of the circumference, pi r times the radius r, so it is pi r times r, or pi r squared. That is the derivation of the area of the circle. So if we encounter a circle, it is automatically pi r squared, or pi times r. So that's the explanation. Circumference is 2 pi r, and it is just half of the circumference because it is just 1/2 of the circle that we are going to use, because the other half is in this opposite side. Then we are going to proceed to the previous example or presented in the let us try activity. So since it is, let's take number 1. This is a cylinder. Then if you are going to get the nets, draw the nets of this, it is composed of 2 circles and 1 rectangle. And the circle has this 5.2 meters, which is the radius, and the rectangle or parallelogram has the 12 meters, which is coming from the height. The length of this is unknown, and if you are going to analyze how long or what is the circumference of this circle, is actually the length of this parallelogram. Okay, so we remember that the circumference is equal to 2 pi r, or pi times d. And since pi is 3.14 times the diameter, which is 10.4, so it is 10.4 times pi. 10.4 is actually 5.2 times 2. Okay? 5.2 times 2. So I will be using the calculator so that you can see. So we have 5.2 times 2. That is 10.4. Okay? So 10.4 times pi, so we're going to use times 3.14 is equal to 32.65, or we round off, it is 32.66. So we are going to right? 32.66, and that's our length for this parallelogram or this rectangle. So we have now the length and we have the width and we have also the radius. Then we have all the information or the data that we need so that we can solve the area of each figure of the nets of this solid figure, which is a cylinder. So let's continue. We have the same 5.2. Then we are going to proceed to the area. The area is pi r squared. So area of one circle is equal to 3.14 times 5.2 squared. And what is 5.2 squared? 5.2 times 5.2 is equal to 27.4. So 27.4 times 3.14, so times 3.14 is equal to 84.91. We just round it off. So 84.91. Okay, so this is our area. The area of this is 84.91, and the same is true with the other base. So there are two circular bases. Then we are going to solve for the area of this, the lateral face. It is base times height, and the base is 32.66 and times 12. So we are going to use the calculator. 32.66 times 12 is equal to 391.92. So 391.92, and then we are going to add this areas. Okay, so it is 84.91 plus 84.91 plus 391.92 is equal to actually 561.74. So I will no longer use the calculator. So you can try to check if the computation is correct. So this is our surface area of figure number 1. We are going to proceed to figure number 2, which is a rectangular prism. So first is we are going to, of course, draw the nets. So you have the top, this portion, and the bottom. So if we're going to draw the top and the bottom, looks like this. It's a rectangle, and the width is 4 inches, and the length is 7 inches. And then 4 times 7 is equal to 28. Therefore, one of the top and the bottom bases has the area of 28 squared inches. And then we are going to proceed to the front. This is the front, and this is the back portion. Okay, so front and back faces, we have the width is 4 inches, and because we are going to use the thickness or the height, then it is 5 inches. Okay, so 4 times 5 is 20 inches squared. We are going to proceed to the right and the left. So this is the left, and this is the right. So right and the left, so we have, this is a rectangle, so 7 inches, and this is 5 inches. So 7 times 5 is 35 squared inches. Then we are going to combine. We have 2 times 28. We need to multiply it by 2 because there are 2 bases. We have the top and the bottom. Okay, 2 times 20 and 2 times 35. So 2 times 28 is equal to 56. 2 times 20 is equal to 40, and 2 times 35 is equal to 70. And if we are going to combine them, it is 166 squared inches. And this is our surface area of this figure, number 2. Okay, so this time we are going to proceed to the let us study activity of your module. So we have the surface area of the cube. We are going to discuss each of the figures, the solid figures rather. So we have first the cube. If it is a cube, it is composed of 6 squares or 6 faces. And since the area of the square is equal to s squared, so we just simply use the formula 6s squared. Okay? So the surface area is 6s squared. For example, the side is 12 centimeters. Okay, sometimes it is using edge. So 6 edge squared. So it is s times s. So 6 times 12 times 12 is 144, and surface area is 864 squared centimeters. If you are going to try to use the calculator, we are going to start with 12 times 12. Remember, or take note, 12 squared means 12 times 12, not 12 times 2. 144 times 6 is equal to 864, and this is correct. Okay, so we're going to continue. So how about this rectangular prism? So in the previous example, I showed to you how to solve for the surface area of a rectangular prism. But this time we are going to have the formula. The surface area of the solid figure is the sum of the areas of its faces. And since it is having the top, the bottom, the front, and the back, which are congruent, and the length and the width, the right and the left rather, then if you are going to get the nets, it looks like this. And if we are going to derive or to come up with a formula, it will be 2 times length times width. This is the length and this is the width. And then 2 times width times height. So width and the height. And then 2 times length and the height. So for example, find the surface area of this one. So this is we can take this as the length, this is the width, and this is the height. So the nets looks like this. So we just simply substitute the formula, the dimensions. The length is 3 and the width is 2. And then we are going to substitute. Width is 2 and the height is 6. And the length is 3 and the height is 6. And then 3 times 2 is 6. 2 times 6 is 12. And 3 times 6 is 18. And then 6 times 2 is 12. 12 times 2 is 24, and 18 times 2 is 36. 12 plus 24 plus 36 is equal to 72. Actually, you can also just get the product of this length width height, and length height, and then you add them, and then you multiply it by 2. Okay, the same results will come out. So it looks it will be 2 times the quantity of length width plus width height plus length height. Okay, the same results will come out. Okay, so if we are going to go back to our example a while ago in the let us try, this is derived from this. We have this is length and this is width, so we have 2L times W, or length times width. This is length and this is the height and this is the width. So this 2 times width times height, and this is the length and this is the height, so this is 2 times length times height. So just distribute them and we will get the same results. Next is the surface area of the pyramid. In this figure, in this example, I'll be using, or the module made use of a square pyramid. So the surface area of a pyramid is of course the sum of the lateral area, which are the triangles, the congruent triangles, and the area of the base, which is a square in this example. So the nets looks like this. The height, the slant height, take note, it should be the slant height which is given, or the height of this triangle, the lateral surface. Because if the given is the height of the pyramid itself, you cannot make that, you have to make use of another formula, which is, first is you need to apply the Pythagorean theorem so that you can find out the height of this slant, or this triangle, the surface, the lateral face. Okay, so take note of that. So in this given figure, the height of this triangle is assuming to be 8 inches. So since the surface area of the solid figure is the sum of its area of its faces, we need to multiply the area of the congruent triangular face by 4. So it is 8 times 5, which is the base. This is the height. So 8 times 5, which is 40 times 4. 40 divided by 2, and then times 4. You need to divide it by 2 because the area of the triangle is base times height divided by 2. So it is 4 times 1/2 BH. 1/2 BH is area of one triangle times 4 because there are 4 triangles. Next is times S squared. S squared is taken from this, side times side, which is a square. Okay. So if you are going to apply, so this is the height, the slant height, which is 8. So 4 times 1/2 times 6. This is the base, and the height is 8 inches. So 4 times 8 is 6 times 8 rather is 48. 48 divided by 2, which is 1 half of 48, is 24. 24 times 4 is 96. And 36 is taken from 6 times 6, which is side squared. So 6 times 6 is 36. 96 plus 36 is equal to 132. And the surface area is 132 squared inches. Okay. So we have the surface area of the cylinder. So the cylinder, the nets of the cylinder is the nets of the cylinder looks like this. It is composed of two circular bases, the upper base and the lower base, and this is the lateral surface, which is actually a parallelogram or a rectangle. So this is the length and this is the width. So if you are going to come up with a formula, it is 2 times pi r h. Where is it coming from? 2 pi r is actually the circumference, because the length of this rectangle is actually equal to the circumference of this circle. And the circumference is, we know that it is 2 pi r times the height. The height is actually the width of this parallelogram or this rectangle. And the height is the height of the pyramid itself, of the cylinder itself. So the height is h, and then 2 pi r is the circumference of this, which is actually the length of this lateral surface. And this is now the area of this lateral surface. Next is, where is this 2 pi r squared coming from? We know that the area of the circle is pi r squared, and there are two congruent circles, then it is 2 times pi r squared. Okay, so that is the derivation of the formula of the surface area of a cylinder. So any cylinder, we are going to solve for the surface area of any cylinder using this formula. Okay. For example, the radius is 4 centimeters and the height is 15 centimeters. Then we just substitute the values. 2 and then 3.14 times the radius is 4 times the height is 15, and then 2 pi r squared. So 2 times 3.14 times r. R squared is 4 squared. 4 squared is equal to 16. And then if you are going to simplify, we are going to use the calculator so that you can see that if the computation is correct. So let's start with 2 times 3.14 times 4 times 15 is 376.8. This is correct. And then let's proceed to this one. 2 times 3.14 times 4 squared. So 4 squared, it is 4 times 4, which is equal to 16, is equal to 100.48. I'm sorry, there should be 4 squared here. Okay, so 100.48 plus this one, 376.8 is equal to 477.28 squared centimeters. And this is our surface area. Okay, so this time we are going to proceed to the surface area of the cone. The surface area of the cone is the sum of the lateral area and its circular base. So let's derive the formula of the surface area first. So this is the circular base, which is having the radius, and this is the lateral surface. The cone should have the slant height. Okay, take note of that. If the given data is the height of the cone, then we need to solve first for the slant height of the cone. And it can be solved by using the Pythagorean theorem, which is the a squared plus b squared is equal to c squared. And it will, I will not include, or I will not discuss that in this video because it is another topic and we need a lot of time for that. But anyway, all the given figures or all the given data in our modules are the slant height, okay, which is represented by small letter s. Okay, if you are going to derive this or the nets, this is the circular base with r, and then if we are going to find the nets of the cone, it looks like this. It is a bigger circle, and we are going to divide it into four sectors, and we are going to use only of this sector. And this is what the lateral surface of the cone looks like. Okay, it is like 1/4 of a bigger circle. Okay, and this is now the slant height, this one. Okay. And we know that this is the circumference of this small circle. Okay, because from here going to here, okay, is the circumference, which is equal to 2 pi r, because the circumference of the circle is 2 pi r, or pi times d, or 2 pi r. Okay. Then the question is, if the area of this is known that it is pi r squared, how about the area of this, which is actually like, it looks like 1/4 of a bigger circle? So we know that it is s, but we do not know that it is what is exactly the measure of this. So we need to remember or recall the derivation of this circle, the area of the circle, which is actually pi r squared. And in this figure, we are going to use pi r squared instead of r, which is the radius of the circle. We are going to replace it with s, because this is the slant height. This is the radius of this circle, or this arc, the sector. So instead of using pi r squared, we are going to use pi rs. Okay? So that is the derivation of this lateral surface, the area of this lateral surface. So we have now the combined pi r squared, which is the area of this circular base, and pi rs. So this is now our formula in finding for the area of the cone. Pi r squared plus pi rs. And we are going to apply. So this is the slant height is 7.25 centimeters. Take note, it is not the height of the cone, it is the slant height. And the radius is 3.5. Then we are going to solve. So pi r squared plus pi rs. So 3.14, and then the radius is 3.5. So 3.5 times 3.5. So let's try to check. I'm sorry. Okay, we are going to check if it is correct. So 3.5 times 3.5. So 3.5 times 3.5 is equal to 12.25. This is correct. Times 3.14 times 3.14 is equal to 38.465. So the author did not round it off, so it is 4.65 at 38.465. Next is 3.14, which is pi, r is 3.5, and s is 7.25. Then we are going to solve 3.14 times 3.5 times 7.25 times 7.25 is equal to 79.6775, and then we are going to add this 38.465. The answer is 118.1425 centimeters. So he did not, or he or she did not round off the answer. So it is stated or expressed in 4 decimal places. But if you round it off, it will be 118, or approximately 118.14. Okay? So we are going to proceed to the next figure, which is the sphere. This is the last figure that we are going to discuss. The area of the circle that contains the center of the sphere is pi r squared. So this is the area of a circle. And it would take exactly 4 of these circles to wrap the sphere completely. Okay, so that is the theory. So I will no longer discuss or the derivation of this formula, but it is the theory. Theoretically, there are 4 circles to wrap around this sphere. Therefore, it will be 4 4 times pi r squared. So it is 4 pi r squared. And to apply that, we are going to calculate the surface area of a sphere with a radius of 3.2. Then we have this one. Just simply substitute 4 and pi, and then r squared is 3.2 squared. And then 4 pi is 3.14, and then 3.2 times 3.2. Let's try to check using the calculator. So you have 4 times 3.14 times 3.2 times 3.2 is equal to 128.6144, and the author rounded it to one decimal place. So it is 128.6 squared centimeters, and this is our surface area. Okay, so those are the formulas in finding for the surface area of solid figures. So if you observe, the surface area is always the lateral area plus the area of the base. So it is like LA as SA, or surface area, is equal to LA plus B, or lateral area plus base. Okay? So this time we are going to answer some of the activities of your module. Let's start with the let us practice activity. So let's start with this one. It is a cube with the dimension 6 dm. So it is 6 times s squared, and substitute s by 6. 6 times 6 is 36, and 6 times 36 is equal to 216 square decimeter. And this is our surface area. Okay, we have number 2. It is a 3 by 4 by 5 centimeters rectangular prism, and we are going to use this formula. Substitute. Length is 4, width is 3, length is 4, and then height is 5, and then width is 3, and height is 5. So 4 times 3 is equal to 12, 4 times 5 is 20, and 3 times 5 is equal to 15. And 12 plus 20 plus 15 is equal to 47, times 2 is equal to 94. Therefore, the surface area of this figure is 94 square centimeters. Okay, if you think that I am very fast in explaining each of the formulas, then you can watch over this video all over again, so that you will gain mastery on how to solve for the different the surface area of different solid figures. Okay, because I need also to make it faster so that it will not take a lot of time for this one video alone. Okay, so let us practice more activity of your module. I guess this is the last part that I will be discussing. All the rest of the activities can be solved using the given formulas presented a while ago. So you have, first, number 1 is the cylinder with radius of 4 centimeters and the height is 15 centimeters. Then we are going to replace with the formula 2 pi r squared plus 2 pi r h. Okay, the formula of the base and the formula of the area of the lateral surface. So you have 2 times 3.14 times r is 4 squared, and then 2 times 3.14 times r, which is 4, and height is 15. So basically it's just substitution. If you have this radius and the height, you can solve the formula of you can solve the surface area of a cylinder. So just have the patience to substitute correctly each of the given dimension. So you have this 4 squared is 16. So we are going to check if the computation is correct. So you have 2 times 3.14 times 16 times 16, 3.14 times 16 is equal to 100.48, which is correct. And how about this one? 2 times 3.14 times 4 times 15 is equal to 376.8. And then we are going to add them, plus 100.48 is equal to 477.28, and this is correct. Okay, we are going to proceed to the next figure, which is a cone. Okay, take note the height we are going to assume that this 8 centimeters is the slant height. Okay, because if it is the height of the cone, then we need to apply first the Pythagorean theorem. So pi r squared plus pi rs, the slant height. So just substitute 3.14 times r squared, which is 6 squared, and 3.14 times the radius is 6, and the height is, the slant height is 8. So we are going to simplify 6 times 6 is 36, and then we are going to check if our computation is correct. We have 3.14 times 36 times 36 equals 113.04, which is correct. Okay, this one, 3.14 times 6 times 8 is equal to 150.72, correct? Plus this 113.04 is equal to 263.76. Okay, that's correct. So this is our surface area. And we are going to proceed finally to the last figure, which is a sphere with a radius of 14 centimeters. Then the formula is surface area is 4 pi r squared, because it needs 4 circles to cover this whole or the entire sphere. That is according to the theory. So 4 times 3.14 times, just substitute 14 squared. Okay, so 14 times 14 is equal to 196. Let's try to check if the computation's correct. So we have 14 times 14 is equal to 196. That's correct. Times 3.14 times 4 equals, I'm sorry. 4 times 3.14 equals 12.56 times 196. 196 equals 2461.76. Okay, this is correct. Then, therefore, the surface area of this sphere is 2461.76 squared centimeters. Okay, so I guess that's all for today, and I hope that you have learned something. And if you learned, please do not forget to share this video and like also this video so that it can help others in learning about surface area. And once again, to those who haven't subscribed yet to my YouTube channel, please do not forget to subscribe and click the notification bell so that you will get updates on my upcoming math tutorial videos. That's all for today. See you next time. Thank you very much for watching. Bye-bye.